At Badger, we're trying to create a mobile robot that can autonomously navigate retail spaces like a Kroger or Walmart-sized space.
So I think our goal is to really equip brick and mortar retailers to run their operation better. The successful path is going to be doing that with data, real information, not just anecdotes and assumptions and things like that. I believe we're giving a very strong case for data-driven decisions that can change business.
In the very beginning, I'm looking at my screen and Marty's just driving around. He's just, completely, seemingly to me, autonomously driving around doing stuff. I don't know what he's doing.
That's a lot of technology in that stack. And watching the team be able to do that, do it well, and again, be what we think is best in class, it's pretty phenomenal.
There's definitely a lot of camaraderie with all the UK grads and alumni around here.
Thought about all the alums we have here, and it's like, oh my God, we're a third, if not more, of UK grads. And it just speaks to the capabilities and that they bring into the job, the experience they have. It's a great core, and I like to brag on the fact that we've got some of the best in the world, kind of homegrown right here.
I actually did not expect to be working in the robotics field as a mechanical engineer, but this internship has really opened my eyes to the robotics field, and I think it's going to be around for a long time, and it's a really great opportunity for me.
I would love to see Marty around the grocery store that I go to. I think about it every time I go into Kroger. I think about seeing Marty just, patrolling around. I think that'd be really cool.
We want to provide something that solves the whole problem, but fundamentally that's it. We want to make sure we provide something that can impact, but it's everything, complete from service to hardware to technology, all that packaged in a usable form.
Drag&bot is a framework for easy graphical robot programming. The software enables workers to use robots in production without expert know-how. It is independent of different robot brands and models. In contrast to existing solutions, robot programs can be created much faster. As a result, drag&bot enables cost-efficient automation of small lot sizes. First, download the software and install it on a regular industrial PC. Next, the robot and other hardware components are connected with the computer. The software allows to easily configure all components. That's it. Now you're ready to use your robot cell. Here you can see the graphical user interface of drag&bot. Depending on your hardware and software setup, different function blocks are available. Using drag and drop, a program sequence can be created. Existing programs can also be reused. Afterwards, the parameters of a function block are defined by using wizards. Another important feature are so-called guides. Guides support the user to automate complex tasks in an intuitive way. The depalletizing guide helps to create a program in 5 simple steps. Picking parts from a grid is a common use case in production. Afterwards, the program can be immediately tested on the real robot. Modules extend the basic version by additional functionality. For example, the computer vision module can localize objects in the workspace. This way, the robot can easily pick the object. Even unsorted parts can be picked from a box. Force-controlled movements enable the automation of complex assembly tasks. Drag&bot supports a variety of different hardware and is independent of robot brands and models. For everyone who wants to use robots more flexible, drag&bot.
Robotics and AI are developing rapidly, but there are still challenges preventing them from being applied to the vast majority of manufacturing, logistics, and service tasks, which require quick decision-making and fine dexterity. Robots of today are simple machines, endlessly and precisely repeating motions that have been hand-tuned by engineers. Available systems relying on commodity hardware are too slow at processing the spatial data required to generate live motion plans. Real-time robotics has invented a specialized processor which dramatically outperforms conventional planning solutions. The speed of our processor enables businesses to maximize throughput in existing workflows and, more importantly, adapt to both process variation and dynamic work environments. In this example task, new motion plans are needed due to variation in pick and place locations, as well as dynamic obstacles in the environment. Our ability to detect collisions in real time creates a system that is safe for employee collaboration. Our toolkit provides a simple interface that allows you to configure our product to your robot, gripper, and vision system. Once configured, our proprietary hardware generates new motion plans as fast as changes can be perceived, eliminating the need for precise positioning or safety fencing, and enabling people and robots to collaborate. Our processor accomplishes this with a data pipeline optimized for motion planning, making it vastly more efficient than general-purpose computers or even GPUs. Real-time's compact hardware requires minimal power and replans thousands of times faster than conventional solutions. Paired with a vision system to identify goals and perceive obstacles, our technology generates collision-free motion plans. As the robot executes a path, the processor continuously validates that the current trajectory is still safe, based on live streaming sensor data. When the path is obstructed, the robot will immediately pause and rapidly plan around the obstacle, maintaining operational throughput. If a safe path cannot be found, then the robot will continue waiting until it finds an opening. This capability not only enables a single robot to avoid obstacles, but also enables many robots to plan independently of one another. Each robot reacts to the other's movements to avoid collisions while continuing its task. Additionally, our processor allows robots to directly collaborate, even in dynamic environments. This example shows one robot assisting the other by picking misoriented objects and presenting them to be placed correctly by the second robot. Real-time robotics technology enables the use of human-safe automation in applications with significant process variation or dynamic activity within the workspace. The speed of our processor overcomes the limitations preventing the spread of robotics. Our user-friendly interface provides easy integration into existing operations, allowing agile customers to change their workflow as needed without re-engineering their automation solution. Real-time robotics, enabling faster than human motion in unstructured workspaces.